We now move into a new chapter in our textbook. We're going to talk about functions. So to get ourselves started, of course, I'm going to look to models. And we actually are going to have, I think, 3 models for functions once we get done. So in this video, you're just going to get one, our first model of functions. We're going to discuss the difference between codomain and range. Those are going to be 2 terms that we define in addition to some other terminology that we have. We're going to show some ways of representing functions, some different ways that we can do that. And finally, we're going to show how to determine whether something that claims to be a function is actually a function or is not a function. So here's our first model of what functions are. I call it the input-output model because it has inputs and outputs. So a function can be thought of as a machine if you're an old-fashioned guy like me, or a piece of code if you're a hotshot programmer like you, that has some set of inputs, and we call that the domain, and some set of possible outputs, which we call the codomain. Each time you put an appropriate input into the function, it spits out some kind of output. And it has a consistency requirement, which means that if you put the same input in twice, it's impossible to get different outputs for each time you put in the same input. So next I want to sort of explain some of the syntax for what you need to define or communicate in order to define a function. You need to tell us what the function is called, give it a name. You need to tell us what the domain is so we know what the appropriate inputs are. And you need to define the codomain so we know what kind of outputs we should expect from our function. So if the function is named f and the domain is the set D and the codomain is the set C, the way you'd indicate that symbolically so that you don't have to jumble over too many words is you'd put f colon D right arrow to C. So the F indicates the name of the function, the D indicates what the domain is, and the C indicates what the codomain is. And then after you indicate those things, that's kind of the setup, you need to communicate which inputs go with which outputs so you know what the function actually does. So let's give an example. So we're going to define a function where the inputs are students at GVSU, and the output for a given student is their first class in the week. So if you give me a student as an input, the output is going to be whatever the first class in a given week is going to be for that student. So the domain's pretty easy to determine from that description. It's going to be the set of all students at GVSU, and we're going to name that set G. Our codomain, well, we know the outputs are going to be classes because it's going to be their first class of the week. So we're going to say the codomain is the set of classes at GVSU. As we will see in a little bit, that's not the only way you can define the codomain, but it's the way that we're going to do it here. And then we're going to define what the function does. How do we say what the inputs and what the output go with which outputs? So we're going to indicate W from G to C to tell us what the name of the function is. We're calling it W. What the inputs are, the set of GVSU students, and what the outputs are going to be, the set of classes at GVSU. And we're going to say that W of X is the first class of the week for student X. Okay. Now we got to describe some of the terminology that, or not the terminology, the notation that we're using here. The input of our function is X. Right, so that's going to be our, it's going to be an element of the domain, which in this case, X means that X is going to be a GVSU student. The output is W of X, so W of X is the output that goes with X. So in other words, W of X is the first class for X. So our definition of what the codomain is may sound a little bit familiar to you. May sound a lot like the definition of something you've seen maybe in other classes called the range. But there's a very subtle difference between the codomain and range that I want to talk about right now. So let's let f from A to B be a function, which means that A is the domain, the set of inputs. B is the codomain that describes what the outputs are like. The range of f is literally the set of all outputs of our function f. Now, as you may see, the wording for range and codomain are very similar. So range sounds a lot like codomain, but I'm going to describe to you why it is actually a little bit different. So what is the difference? Well, let's see. So the way we defined our function W, our codomain was the set of all classes. So W of X was the first class of the week for student X, and C was the set of all classes at GVSU. Now, it is possible, in fact, it is probable, that there are some classes out there that are not the first class of the week for any student. For instance, if you have, if you have a class that meets once a week on Thursday night, it's probable that nobody in that class has that class the first time. They probably have it earlier in the week, like on Monday or Tuesday. However, we do include that in the codomain. So in this case, our range is literally all the courses that are, not all the courses, but all the courses that are the first class of the week for somebody, some student. And the codomain is literally all the classes at GVSU. So you can see there's a difference between the range and the codomain. Well, a reasonable question to ask is, well, why don't we just define the codomain to be the range all the time? Well, in this particular example, there's a super good reason, right? Describing the range can be really difficult and really tedious, right? So imagine in our GVSU first class function, we'd have to look at everybody's schedule and figure out what their first class was and then include those things in a list, and that would be our range, right? We don't want that for the codomain. It's very complicated. Just saying all the classes at GVSU will include all the classes that we want, all the classes that are first classes, and may have a few extras, but it's a lot easy to describe. The second reason is describing what the range is not a super urgent task. It is really important for us to know what the inputs are because we want to know what are the appropriate things to put in this function. But for the outputs, we usually only care in the beginning about what type of object the outputs are, right? So in this case that we were looking at, we only care that the output is going to be some course at GVSU. We don't care which ones are actually going to be outputs and which ones are not. We just care that it's going to be a course at GVSU. All right, so that finishes our discussion about codomain and range. Now I want to talk about different ways that we can represent a function. So we've already seen one way that we can do it. We can give a verbal description of which inputs come with which outputs. And that was our student first class function that we were talking about just now. You can represent a function with a formula. So if I have a function, say, going from the real numbers as our inputs to our outputs being also real numbers, we could say that, f of x equals x squared plus 3, and that will indicate, that x is our input, right? If x is our input, and what this is telling us is in order to get your output is take your input, square it, take that number, add 3, and that gives you your output. We can literally just list all the ordered pairs that describe the function and what we mean by it. And so if, say, we had a function, the inputs are 2, 7, 10, and 15, and the outputs are going to be natural numbers, we can just list f as a set of ordered pairs. In this case, the x coordinates are going to be the inputs, the y coordinates are going to be the outputs. So for instance, if we cared about what f of 7 is, we'd look at where 7 is an input, i.e. an x coordinate. There it is, right? 7 is an input on the left. And that means the output that goes along with 7 is the y coordinate, which is 1. We can represent a function using an array. So here's a function where the inputs are 1, 3, 4, 5, and 6. The outputs are going to be some kind of integers. And then our f is going to literally equal this array. And so what's happening here is the top row, that is going to be all of our inputs. You can actually see that, compare that with our domain. And then the bottom row is going to be all the outputs that go with those inputs. So for instance, if I care about what f of 4 is, I'm going to look up where f of 4 is an input, or where 4 is an input, that's on the top row. And then the number right below that is going to be the output, which is -5. In Python, we have functions galore. We actually have two types of functions. One is literally called a function, right? And they usually have some kind of input variables, and then their outputs can be various types of things. They can be numbers, they can be objects like lists or things like that, or even just actions, right? It could be you just have some kind of input into your function, and then it does something in response. But another thing in Python that is a lot like a function is actually dictionaries. In this case, our keys are going to be our inputs. The values in our dictionaries, those are going to be the outputs. So the key is the input. The value that goes with that key is going to be the output. And if you look carefully at the definition of what a dictionary is, the rules of making dictionary guarantee that you have a function. In other words, in a dictionary, you can't have one key that has two different outputs. If you try to do that, if you try to define a function where you have one key that shows up twice with different values, Python's going to barf at you. If you want some other representations, if you look at pages 40 to 45 in the textbook, or if you're using the web page version, you look for the place that says describing functions. You can find some other representations too. The main theme with all of these is use some form of communication, clear communication, to tell what the inputs and outputs are. All right, so the last issue that I want us to deal with is sometimes you have something that looks like a function, smells like a function, you think it might be a function, but it might not be. So I'm going to sort of show you some of the pitfalls of these types of things. But before that, we're going to actually recall the definition. Each time you put in an appropriate input, the function returns some kind of output. And if you keep putting in the same input over and over again, it's going to keep giving you the same outputs. There's no way you can put in the same input twice and somehow get two different outputs. So the question is, how can we tell if we don't have a function? And I'm going to show you an example. So here is a supposed function whose inputs are real numbers and outputs are also real numbers. And we're going to define it using a formula. It looks a little weird, but looking weird doesn't necessarily mean it's not a function. We're going to say the output f of x squared is equal to the input x. And anything that satisfies that equation tells us that the input and output relationships. So for instance, if I want to find out what f of 4 is, what I'll do is I'll put it into the formula. F of 4 squared is equal to 4, and I think, what's a number that I know where I square it and I get 4? Well, f of 4 equals 2. So if 4 is the input, 2 is the output. But, well, if I have f of 4 squared equals 4, and I was thinking of it a different way, I could also have f of 4 equals negative 2, right? Because if I square negative 2 times negative 2, the negatives cancel, still get 4, right? So this tells me that I have an input 4 that gives me two different outputs. F of 4 equals 2. That's one output. F of 4 equals negative 2. That's another output. That is not allowed. I can't have the same input with two different outputs. That tells me that it's not a function. All right, so now that I've given you an idea about some of the issues related to functions, the name of the PDF file that goes with this video is called Introduction to Functions. Go ahead and have some fun with that one.